problem. At Monte Vista High School, there are a total of 60 students. 3/4 of the students like chocolate ice cream, 3/5 of the students like vanilla ice cream, and 1/6 of the students do not like either. Find the fewest number of students who could like both chocolate and vanilla ice cream. After reading a problem like this, we should immediately be thinking about a Venn diagram, as the problem involves two types of students, those who like chocolate ice cream and those who like vanilla ice cream. For those of you who do not know what a Venn diagram is, it is when you have two groups, in this case ice cream flavors, which represent two circles. An example may look like this. Notice this area in the middle. This is what we call the intersection of two Venn diagrams. If we have a group called chocolate and a group called vanilla, then the intersection is the number of people who like both chocolate and vanilla. Now let us return to the problem at hand. Since 1/6 of the students don't like either vanilla or chocolate, they will not even be considered in a Venn diagram. So we can simply subtract this information out. So 60 times 1/6 is equal to 10, and 60 minus 10 is equal to 50. This number will become important later on. Now let us calculate the number of students who like vanilla and chocolate. There are a total number of 60 times 3/4 students who like chocolate, which is equal to 45, and 60 times 3/5 students, which is equal to 36, who like vanilla. These numbers seem strange because if you add the two, you get 81, which is definitely greater than 50. But remember, a student can like both vanilla and chocolate ice cream. This means that a student who likes both ice creams will be counted twice, because the student is counted within both the chocolate and vanilla category. Think of it this way. There are 45 students who like chocolate. This number in the Venn diagram would be represented as the following shaded region. 36 students who like vanilla would be represented this way. Notice how our intersection is shaded twice. This means that we are counting this value twice, which is not correct because one person cannot represent two beings. A solution to get around this issue is to solve the following. Calculate the number of students who like only vanilla plus the number of students who like only chocolate plus the number of students who like both vanilla and chocolate is equal to 50. The reason this is 50 is because we are ignoring all those students who don't like either vanilla or chocolate. Only vanilla in a Venn diagram is this region over here. It does not include the intersection because these students like both vanilla and chocolate. Only chocolate is represented with this shaded region. Once again, it does not include the intersection. Let us define the variable x as the number of students who like both chocolate and vanilla. So in this case, that is the intersection. Then to solve this equation, that is the equivalent of writing 36 minus x plus 45 minus x plus x is equal to 50. The reason we have 36 minus x is because we are considering the number of students who like vanilla and then subtracting x because that is the intersection. The same thing applies for 45. We are only considering the number of students who like chocolate, which is this entire region over here, but we're subtracting out the intersection, which in this case is x. And finally, we are adding x because by definition it represents the intersection. So this is how we represent this formula. After solving this, we get 81 minus 2x plus x is equal to 50. Therefore, negative x is equal to negative 31, and so x is 31. Now you may be thinking, wait a minute, doesn't the problem ask for the fewest number of students who like both vanilla and chocolate? The answer to that is yes. However, there is only one possible value of x that can be used to satisfy the equation above. Therefore, we're only considering the minimum of one value, which is 31. Thank you for listening.